Hello, this is the video for 7.3 Transformations 1, the skills section. We're going to be looking at three different types of transformation: reflections, rotations and translations. And quite a bit of vocabulary that goes with them. The first transformation we'll talk about is reflection. That's where if you've got an object, you are reflecting it, so flipping it or turning it over. So these would be reflections. When you are doing one of these on paper or on a test, you've got a line which you might be using, and you either are given that line or you need to work out that line. So here the line is x equals 3. You need to go back to line graphs possibly to work out what these mean. But the mirror line means that it is the point that is going to be exactly between the two shapes. So here where they say corresponding point are equidistant, that means that our mirror is exactly between the two shapes. So all the points on A are the same distance away from the line as the points on B. You wouldn't imagine looking into a mirror and seeing yourself closer. The second transformation is rotation. That's where we are turning the shape. So there I've just turned it clockwise 90 degrees because a clock goes this way around. So clockwise 90 degrees, another 90 degrees makes it 180, another 90 degrees makes it 270, 360 puts us back where we are. So if I'm going to describe a rotation, I need to know the angle that it's going to be turning in, the direction, whether it's clockwise or anti-clockwise, and also the center of rotation. So if I was picking this corner as the center, I would be turning the shape around the corner. So that point there is not going to move. I can't do it very well with this, but you understand possibly. But if I was going to pick the center of the shape as the center of rotation, then the shape would rotate around the middle. In exams and tests, you're only going to be using 90 degrees, 180 degrees and 270. So you shouldn't have any angles which are odd and not at right angles. The final transformation in this section is translation, which is moving. I describe it in lessons as cutting and pasting or copying and pasting, because you are not rotating, you are not reflecting, you're not enlarging the shape. It is literally just moving the shape somewhere else. So you could be going up a bit, left a bit, right a bit, or down a bit, but it is no way turning the shape. So the shape will always appear the same. A little bit more vocabulary that comes with this section are the words object and image. Object is the shape you start with, and image is the shape that you produce. So if I start with this shape and I need to reflect it, then this is the object as you can see it right here, and then the image is over here. The word congruent means that the shape has not changed size. You can rotate it, you can reflect it, you can translate it, but it has not changed size. All the angles are the same and side lengths are the same. Now, a higher level skill is using a vector for translation. This is where you have two brackets and two numbers showing a direction of where you would be moving. And I normally draw this picture. Okay, so the number at the top describes our left and right movement, and the number at the bottom describes the up and down. I put pluses and negatives because a positive number at the top means it is moving to the right, and a positive number at the bottom means it is moving up. So if I pick this vector and I just choose a random point here, this means I'm going to go 5 to the right and 3 up. 5 to the right, 3 up. So this point goes 1, 2, 3, 4, 5. 1, 2, 3. This vector here says it goes 6 to the right, and because I've got a negative 1, it's going to go 1 down. So if I choose this point, it's going to go 1, 2, 3, 4, 5, 6, and then down 1. Okay, so that goes to there, that goes to there. Negative 2, negative 2 means I'm going to go 2 left, 2 down. So if I choose a point, I'm going to go 1, 2, 1, 2. So my object points turn into image points, and I can do this for the entire shape when we start looking at moving shapes with translations. The example in the textbook asks us, if we start at A, the object, how do we get B, C and D, the images? So what transformation is required? I'm going to use tracing paper for this, so some sort of see-through paper, which means that I can see through the things underneath. Using this, the first thing I'm going to need to do is draw over the shape. Okay, I've got a pencil, so if I make mistakes, I don't have a problem. It doesn't have to be perfect. Using this and focusing on B, I can see that it's probably going to be a reflection, because if I move that over the top, I fit perfectly onto it. Okay, so all I need to do is work out where the mirror line is. Okay, and as we said earlier, the mirror line is going to appear exactly between the two shapes. So here, these are 2 apart, so I would have the mirror line definitely needs to go through there. Here, these are 4 apart and supposed to be the same corner, so I would have the mirror line going through here, which means the mirror line is going to be here. Okay, the mirror line is going to go on forever, but I did miss, got a bit of paper in the way. I've written there that exactly what we've learned from earlier, the corresponding points are equal distance from the mirror line. If we need to name this line, it's a vertical line passing through 4, so this is x equals 4. So you could say A to B is a reflection across the mirror line x equals 4. Going back to my tracing paper, here we have that. I can see that C isn't the same direction. The image, it's not got the large bit at the top like this bit and the short bit at the bottom like this one. So it's not going to be a reflection. And actually, if I think about it and about turning things around, then it's going to be a rotation. And to work out how things rotate, I'm going to again use the tracing paper. So if I put it on top and choose a point and put my pen in it and then turn the shape around, and I'm trying to find where my tracing paper lines up with this shape, I've not found the right center yet. There's no way that that is going to get onto that part. So I'll restart and I'll choose this corner here. Again, I'm just doing trial and error really, but I can picture that that's going to turn around and fit perfectly onto shape C. Okay, so that point there, which is the point where they sort of line up really, where they match up, the point 1, 1, using the graph, that is where the centre is going to be. And thinking about how much rotation I did, I rotated it clockwise 180. Okay, so if I check, that's where we start. That's 90 degrees rotation. That's 180. Okay, so the shape to go from A to C is a 180 rotation about the point 1, 1. 1, 1 is the center. I put the angle in that I need to rotate. I haven't actually put the direction because a clockwise rotation of 180 is the same as an anti-clockwise rotation of 180 because they're both going halfway around the circle. The final shape D looks like it's the same way round, it's the same orientation. The large bit is at the top, the small bit's at the bottom. And unlike B, it's not flipped around because we've got the diagonal being on the right hand side. So this one is going to be a translation. And all I've got to do is basically count the squares of how it moves. So here, this corner goes to this corner, matching up pieces. So it has gone 1, 2, 3, 4, 5, 6 to the left, and it's gone 1 down. Now, thinking about vectors from earlier, that means I've gone negative 6, because if you think that is the negative part of the graph, we're going left. So it's minus 6 to the left, and it's also down 1. And again, we're going down, so it's negative. So this is a translation of minus 6 minus 1. Alternatively, if you don't need to write a vector, you could say that it is 6 left, 1 down. So the three have been used here. We have reflection, rotation, and translation.